So we're going to learn binary search tree. Binary search tree is one of the different kinds of binary tree. So we are going to learn how to create a binary tree and how you insert the node while creating the tree, binary search tree, and then how to delete a node from a binary tree, binary search tree. So now here this is a set of nodes that is data that is given over here. So how are you going to create a tree from the set of data? So the first number is 11. You're going to consider this as root node, and the second number is 6. So when you pick each and every data, there are few conditions that you have to follow. Check whether 6 is less than or equal to or greater than the root node. If 6 is less, it will go to the left side, and if a number is greater than the root node, it will go to right side. So 6 is less than 11, so it will go to left side. Next is what? 8. It will check whether 8 is less than 11. So it is less than 11. Again it will come and check over here whether 8 is less than or greater than 6. So 8 is greater than 6, so it will go to the right hand side. Now next is 19. Check whether 19 is less or greater. So 19 is greater than 11, it will go to right side. Next 4. Is it less? Yes, it is less than 11. Is 4 less than 6? Yes, so it will go to the left side of 6. Next 10. Is 10 less than 11? Yes. It will check here. Is 10 less than 6? No. 10 is greater, so you got an idea it has to go to the right side. Is 10 greater than 8? Yes. So it will go to the right side of this. 5. Next is 5. Check whether it is less. 5 is less. 5 is less. 5 is greater than 4. So it will go to the right side. Next is 17. Check whether 17 it is greater. So it has to go to the right side of this. Now check whether 17 is less than or greater than 19. 17 is less. It will go to left side of 19. Now next 43. Check whether 43 is greater than or less than. It is greater, it will go to right. Is 43 greater than 19? Yes, it will go to this. Now 49, it should, of course, should be right. It should be right because 49 is greater than 19. Here 49 is greater than 43, so it will go to right side. The next one is 31. So you keep on checking. It is greater, it is greater, it is less. So 31 is going to come here. This is how you keep on inserting a node inside a binary search tree. Now next thing is how to delete a node from a binary search tree. BST, binary search tree. So now here there are three ways. There are three conditions before you work on a deletion. If a node is having 0 child, how do you delete it? If it has 1 child, how to delete? If it has 2 child, how to delete? So here a node which is having 0 children is 5. So if you want to delete this 5, you can just remove this link is fine and just free this node. So if a node is having no children, so these are the nodes which is having no child. So 5, 10, 31, 49, 17. If you want to delete a node which don't have a child, you can just simply take off the link and free that particular node. Okay. Now next condition is if it is going to have one child. That means a node which is having one child, what you have to do? So 4, if you want to delete 4, but 4 is having one child. So what you are going to do here is, before you delete 4, you replace this part with with the one and only child. So you are going to replace this 4 with 5 and delete that 4. So what are you going to do here? This was a condition. So what you have to do, you want to delete 4. Before you delete 4, you put this 5 here, or you can give the link of 6 to this 5 and delete 4. This is how you have to do. So now next one is Now here, if you want to delete 8, what do you have to do? Instead of 8, you just give this 10. This replace that one and only child with that particular node what you want to delete. So that is how, see now here in this case, 19 you want to delete, but 19 is having 2 children. You cannot do anything. That's not the condition for that. There is another condition for 2 child. So now next. So I hope you got how to work on one child. If you want to delete a node which has one child. Now next is what? A node which has 2 child. So now let's draw this tree once again. So it is 11, then 6, then 8, then 19 comes here, 4 goes here, 10 is going to come here, then 5 is going to come here, 17 is going to come here, 43 here, 49 here, and 31. This was a tree. Now next condition is what? If you want to delete a node which has 2 children, so in that case there are 2 cases to go ahead with that deletion. So you can go ahead with in order predecessors and in order successor. Okay, so what you have to do here is you get the in order for this tree. So you've already learned how to traverse a tree using in order. So the in order would be like this. In order is what? First left, then root, then right. So first left, root, then right. Okay. So go up 6, then 8, then 10, then 11, then 17, then 19, then you're going to get 43 and 49. This is how you get the tree. This is the in order. So what you have to do here is, now if you want to delete 11, okay, 11 is having 2 children, right? So what there are 2 cases. The first case is in orders predecessors. So 11's in 11 here in 11, who is the predecessor, that is just before 11, who the person who is just before 11 is 10. So what you have to do, just replace this 11 with this 10. That's it. That's what the rule is. Or in other cases, there is a second option. You can either go for in order successor. Who is the successor of 11? 17. So you can replace either with 10 or you can replace with 17. Just take that 17 and put it over there. Okay. So if you have, so now if you want to delete this node, that is 43 has 2 children, right? So what is it? Either you have to go for 43's in order predecessors or replace it with the successor. So now if you want to delete this 43, either put 31 up or you can take 49 up. This is a rule for deleting a node which has 2 children. Okay? 2 children. I hope you got it. So this is the logic of binary search tree. So you have the code for binary search tree in your last program. How to create. The create function is exact code for inserting a node inside a binary search tree. And deletion, I can share you the code in Google Classroom. Okay, thank you.